Welcome back again. This is part 2 of the slope fields. We finished off with this problem. Hopefully you finish this slope field by plugging in all the rest of the x and y's and coming up with your slopes. And if you see that, it was a little bit more complex. Not much, though, with the x's and y's. In class, when next class we see each other, you're going to be doing a lot more of graphing those slope fields, all different types of slope fields. Now let's talk about what I kind of envision a slope field. I don't know if you know this, but when I grow up, I want to be a weatherman. And here is a map of some weather. This is the jet stream analysis. And if you look, there are just a bunch of little arrows going across the country. And if you know anything about the jet stream, it's kind of a pocket of air that is above at a certain altitude that kind of moves a little bit faster than the other air. And it kind of controls our weather a little bit. If you notice, this is kind of how cold fronts and warm fronts kind of move in. And but this reminded me when I saw this of a slope field because it gives us the direction of weather or air as it kind of moves across the world, around the globe, and it's represented by little arrows. Here's another example of that. Let me show you. Let me see if I can find today's jet stream right now. I know we have an impending storm coming a little bit later. Maybe they're calling for 1 to 3 inches of snow. But here's today's jet stream right here, what it kind of looks like. And depending on where that pocket of weather is, if the weather's up here, that storm coming, it would kind of take this kind of track and hit us, go up north. If it was coming down south and pulling up the moisture from the Gulf of Mexico, and well, it would be a little south of us. We wouldn't get that. So we're hoping that if there is a storm coming today and we're going to get a couple inches of snow and maybe, I don't know, a delayed opening tomorrow or something, we would want it right in here. All right, so it's a direction field is another name for a slope field, or like I said here, a jet stream map. Moving on. Oh, there's another picture of one. Wow, crazy looking. I want you to match. I had all these nice graphs, like matching each differential equation to the slope field, and I thought, you know what, I really want you to find something interactive to play with. So I'm going to give you a little demonstration here of a site that I found that I think you'll really enjoy. I know I did. It's an applet. You can see right here, if you really wanted the URL, the http semicolon or colon / www.calculusapplets.com / slopefields.html. So what this is really cool is you can change your window from -5 to 5. That's your x's, and your y's, -5 to 5. You could do that. But then you can plug in all different types of differential equations. Here is x. Now we've had enough experience with differential equations now to know that if I were to solve this differential equation, we would get x squared over 2. And look at this. Isn't this look like x squared over 2? It sure does. Now if you remember from our lesson on differential equations, we have general solutions and particular solutions. This pink line right here, going through the point 0, 0, will be considered a general or a particular solution. I'm hoping you said a particular solution, because it is. It's going right through it. Now suppose I wanted it to go through another point, not 0, 0. I would just simply go, I want it through the point 2, 0. Now look, it still looks parabolic, and it is, but it's now going through a different point. So the general solution, the particular solution has changed. What if I wanted to go through 2, -3? If you can see right away, it changes immediately the particular solution. And this slope field is just showing the direction of where this curve would go. I think it's pretty amazing. And if you don't enjoy this, then, well, it's too late. You can't drop the class. It's March. That's not March, it's February. Oh my goodness. All right, here we go. So let's change the differential equation. Let's go a little crazy here. Let's go x squared. So right before I even hit enter, I should say, all right, what should my differential equation look like if I were to solve this for y? I know how to solve differential equations. I'm going to leave it at the point, let's go 0, 0. We'll just make it easy for our lives here. Well, right away you see the slope field changes. And there's my particular equation. Well, x squared is going to give us a cubic, and that is a cubic. So depending on where you want your particular solution to go through, negative 3, 0, look at that shape. That's all you kind of see on there. Negative 1, 0, there you see. You can see the equation there. I think this is really cool. I'm so happy to be able to find something like this to kind of show you, because I could not do this in classes. As much fun as I'm having here. Let's try something a little bit more complicated. Let's do x minus y. Now what you're going to have to do is you would have to look at a differential equation and match it to its slope field, or look at a slope field and match it to its differential equation. So what I'm hoping you do is play around with this applet a little bit and see. Whoa, look at that. Now look at the shape of this. So it's coming down, and what they're really doing is, how they're graphing this is they're making these little tangent lines. Little tangent lines. Those slope fields are little tangent lines to kind of get the flow, kind of like the jet stream. An impending storm coming, this is the path it would take. Our particular solution, this is the path it would take. Now let me try, what's going to happen down here? It's not going to look like that shape. So let me go down a little bit. Let's do 0. Oh, let's say negative 2. Let's see what that, wow, different type of particular solution. The shape of it even looks different. But again, these slopes in the slope field, these little things are just like little tangent lines to the curve. That's an x minus y. Oh my goodness, let's do x divided by y. Let's see what that looks like. Wow. Now how would I know that this? Well, there's a couple ways you can match this. You can just pick a couple of these points and say, okay, 0, 0. Well, I'm going to be undefined at 0, 0. Because I can't have 0 in the denominator. If you notice, they didn't graph those vertical lines that I mentioned before of how they would do it. But then you can just pick a few of these points, x, y's, and see if they match up with the slope. You can see here that when x is negative and y is positive, all the slopes are negative. Down here, when they're both negative, both x and y, they're positive, and along with each quadrant. So I'm hoping that you take some time, find this applet that's up here, find it, and just have some fun with it. You can do anything with it. X squared plus 2y. Let's see what that does. Crazy looking slope fields. Look at that thing. Crazy. And you can change the particular solution where you want it to go through. Wow, look at that. That is really fun looking. I'm sorry. Did someone say they wanted to know what happens when we have trig? That's what happens when you do trig. I don't know why there's an error message there. I wonder what, maybe I'm not putting it in correctly. Parentheses, see? Look at that. Learn something new every day. Wow, there's sine x. You want to see maybe a secant x? Let's see how cool that looks. Whoa! Look at that. Differential equation. So again, in class, you're going to have an opportunity to actually match differential equations to slope fields. You might even have a slope field that you have to match it to the differential equation. Take some time, play around with this a little bit. Look at those different particular solutions. Understand. Go check out a jet stream. Go look at a Doppler. Look at this direction field. And maybe I'll do my weatherman impersonation for you in class if you asked nicely. All right. Well, I hope you enjoyed this video. Please check out the calculus applets, and we'll see you in class. Johnstone, over and out.